No, I got to call Apple support first. All right, so first thing we're going to look for, we're going to factor is what? GCF. What's the GCF of those three terms? Everybody's got an X. So we're going to pull an X out to the front. What's that going to leave in the parentheses? Good. Okay. The next thing we want to try to do is factor what's left in the parentheses. How many terms does it have? 3. That means X method. 1 times negative 15 be negative 15. That goes up top. 2 in the bottom. What multiplies to be negative 15 and adds to be positive 2? 5 and negative 3. Good job. So the factors would be X plus 5, X minus 3. I can go straight to those factors because what's in front of X squared? 1. And then don't forget the X that we pulled out at the beginning. And now we have factored a higher degree polynomial out of that. It's not too bad. I mean, it's just following the process more or less. 2y to the 5th minus 18y to the 3rd. A little shorter problem, but is it in descending order? Yeah. No like terms. Not too often that they're going to need anything done like that when they're just asked to factor. So what's the GCF? Or is there a GCF?
Yeah.
Okay. What's that leave in parentheses? Squared minus 9. Next thing I want to look at is can that part in parentheses factor any further? Sometimes it won't. I think this one will because it's y squared minus 9, which would be a difference of squares. So what are the factors for that piece? Y in the front of both of them. Plus 3 and minus 3. Good job. There's the factored form of that polynomial. All right. Not bad. Sample C. Let's say we had 4x to the 4th minus 16x to the 3rd plus 16x squared. We're going to have to factor that. In descending order, check. No like terms, check. GCF. 4x to the second, good. What's left inside? What's the first term? X squared. Because what times 4x squared gives me 4x to the 4th? Don't forget that little piece there. And then negative 4x is next. And then the last term is plus 4. I made my parentheses too long. Then we try to factor the part left in parentheses. It's a trinomial, so I'm going to try it with that X method. It's got 3 terms. Multiply to be positive 4, add to be negative 4. Negative 2, negative 2. So the factors would be x minus 2, x minus 2. Or I could write that as 4x squared, x minus 2 squared. Either of those, I don't have a preference as to how you write that at the end. Just understand that they are the same. Okay. So not too bad. You're just talking about, factoring, using the same methods you used in Algebra 1 to factor. These are really not anything. Where we get into more of an Algebra 2 type things when we start throwing in that sums and differences of cubes. So I'm going to show you the patterns that you need to memorize for those. And they're not real hard if you just latch on to the idea of separating them a little bit. So we're going to take a sum of cubes. A sum of cubes means you're doing what with two things that are cubed? They're adding them. So it's like a cubed plus something else cubed. The way those factor every single time is you've got a short piece and a long piece. And that's the way you want to think about this, that they've got a short piece and a long piece. The short piece is the easiest one. Okay, the short piece is always going to be, if I can rewrite that sum of cubes as something cubed plus something else cubed. I'll give an example with a number in a minute. The short term is always going to be the same, except for you take the cubes away. So it would be a plus b in the short little piece there, a plus b. Always going to match that. Okay, on the sum of cubes. On the difference of cubes, we'll go ahead and, because it's the pattern's the same. That's a cubed minus b cubed. The short piece, a minus b. It's always the same. The longer piece, and I'm just going to tell you how I remember this, how I memorized it. I'm not very good at memorizing things. I looked at it and I said, okay, if I used one of the a's here, how many are left? 2. So that would be a squared, right? If I use one of the b's here, how many b's are left? 2. So that's b squared. So the front and the back are those pieces. A squared, b squared. A squared, b squared. It's always a plus sign here. And the way I remember that is when you square something, what kind of answer do you always get? Positive. Right? So that's the way I remember. That's always a plus. The middle piece, it's a trinomial that's left in that big long parentheses there. The middle piece, that's maybe the tougher one to remember. In a sum, it's minus AB in the middle. In the difference, it's plus AB. But notice everything, as far as position-wise, is the same. The sign just changes in the middle. The sign in the middle is different, okay, in the long piece. Okay. All right. Let's look at some examples with actual numbers and variables in there, and see if we can do one of those. So example D, x to the third power plus 8 is what we'll start with. Really easy one to start with. You're not going to get too big of numbers here because when you cube something, it gets pretty large pretty fast. 2 cubed is 8. 3 cubed is 27. You already jumped up quite a bit there. 4 cubed would be 64. 5 cubed is 125. That sort of stuff. So let's rewrite that as something cubed plus something cubed, since it's a plus sign in the middle. So if I rewrite that as cubes, x cubed plus 2 cubed. So this is like a and b. That's what that's like. So where our pattern then has a short piece and a long piece. What's the short piece for this one? X plus 2. The front of the long piece, x squared. The back of the long piece would be what? 2 squared, which is 4. In the middle, 2x, and is it a plus or minus? Minus. You don't even have to try to factor what's left. In the long piece, it won't factor ever. The 4 is 2 squared, so it's taking the 2 2's that are left over and squaring them. And then the middle piece, 2 times x, and change the sign. What do you mean switching the numbers?
A and B is X and 2, and A and B.
Well, it's because it's a number. Our kind of convention of math is to write it as 2x instead of x2. So that's just standard form there. All right, let's look at another one. Example E. Let's do x to the third minus 27. So we're still going to do the same things that we did in the first three examples. We're going to look at see if it's in descending order, if there's a greatest common factor, that sort of thing, and then we're going to count the terms. There's two terms there, and we see a third power. That's what triggers us to think, oh, it's a sum or a difference of cubes. This one would be a difference of cubes. What cubed is 27? 3. So what's our short piece? X minus 3. The long piece plus 3x plus 3 squared, which would be 9. You know, and the way we can check that would be take this and distribute it out to the trinomial, and it simplifies out to be that star. That would be the check just to make sure everything is right on that.
So if like A is like a variable, you just put it behind B.
Yes, yeah. Whichever one's a number, yeah, you put it in the front. That's really all that means there. Let's look at one where maybe it's got not just a plain variable in the front, maybe it's got something else, like 8x to the third plus 27. So we'll stay in the same family of numbers there. So we're not having to think too hard about that and really focusing more on the pattern. So do 8 and 27 have a greatest common factor? No, we still have to check for that stuff. So don't think we've abandoned that idea. We still check for that. But then we look at it and say, okay, there's no GCF. How many terms are there? There's 2. So that's either got to be a sum or difference of cubes or a difference of squares for me to factor that. So this is a sum of cubes because we got x cubed there. So I want to rewrite that as something cubed plus something cubed if possible. Won't always be possible, but I'm trying to on this one. I'm picking ones that are. So what cubed gets me 8x to the third? 2x. What cubed gets me 27? 3. Same thing you got it a while ago. What's the short piece? 2x plus 3. What's the first term in the long piece? 2x all squared, which would be 4x squared. Good. Because this is where that's coming from, guys. 2x and then square it. You're squaring whatever was cubed here. Because you used one of the 2x's here. There. What cube gives me the 8? That's where the 2. I'm breaking that down into what cube gets me the first term. What cube would get me the first term is what I'm getting that from. What's the second term in the long piece? Minus 6x. 2x times 3 is 6x. Negative 6x is what we want to use there. The last term plus 9. And that would be my factored form. Let's do 2x to the fourth minus 54x. We're just asked to factor that. What would I do first? Which is 2x. GCF of a 2 and an x. What's that leave in the parentheses? X to the third minus 27, which